Hello, in this video for MAC2233, Calculus for Business and Social Sciences, we'll be going over Chapter 6, and specifically 6.1, the indefinite integral. What we'll be talking about is antiderivative. The antiderivative is the opposite of a derivative. So if I was going to say, what is the derivative of x squared plus 4? The derivative is 2x. So the antiderivative of 2x is x squared plus 4. But the problem is, if I take the derivative of x squared plus 30, that's also 2x. So another antiderivative of 2x is x cubed plus 30. Same thing for x squared minus 49. The derivative is 2x. And so the idea is that if we took a derivative of any number, it's 0. So when I work backwards, how do I know what that number is? So what we do is we put a plus c, because it could represent any number. So, and how quickly we do antiderivative is if I had 2x, there's your antiderivative, and I want to work backwards to find the original, you leave the number in front, add 1 to the exponent, and divide by that number. So I add 1 to 1, that's 2, and then divide by 2. 2 divided by 2 is 1, so we're left with 1x squared, and then we put a plus c for the number that could have been there. Now, the question is, why does that work? Well, remember, when you take a derivative, the 2 goes to the front, and we subtract 1. So we multiply by the 2, and we subtract 1. Well, the opposite is instead of subtracting 1, we add 1, and that new number is 2, and instead of multiplying by that number, we divide by that number. So it's the opposite. So, another way to talk about indefinite integral, antiderivative, is an indefinite integral. So they mean the same thing. So it has this integral symbol here, and the reason why it's called an indefinite integral, this is an integral symbol. The indefinite means there's no lower bound or upper bound, and we'll deal with that later. Okay? So if I was going to read this statement, it would be the antiderivative, or integral, of 2x with respect to x equals x squared plus c. Now, the dx part means with respect to x. And you're probably wondering, well, we always take the derivative of x. Well, remember, it could be any letter. So this is to tell us that we're taking the derivative of x, or with respect to x, or with respect to y, or z. But again, for us, we're just dealing with x. And then c is the constant of integration. It reminds us of what we can add or subtract, same thing, to get the antiderivative. Because remember, when you take a derivative of a number, you get 0. So it's just a brief introduction. So if I was going to take the antiderivative or integral of x with respect to x, what would I do? Well, this is x to the 1, so I'd add 1. 1 plus 1 is 2. And then I would divide by the 2. So the antiderivative of x, or the integral of x with respect to x, is x squared over 2 plus c. Got to have that plus c, because if there was a number there, it's represented now. Now, to check it, we take the derivative. Well, the derivative of x squared, the 2 goes to the front, subtract 1, we get x. 2 divided by 2 is 1, 1x. And then the derivative of any number would be 0. So we can check the antiderivative by taking the derivative, and we should get the original back. So, here's some rules for the indefinite integral. We've already talked about when we have like an x raised to a number, any number, you add 1, and then divide by it. Don't forget your plus c. So if I had the integral of x to the 55 with respect to x, I'd add 1, and then divide by it. So it'd be x to the 56 divided by 56, but don't forget your plus c. Now, the next 3 are our special cases. But remember, the reason why they work is, if you take the derivative, work backwards, you get the antiderivative or the integral. So, the integral of x to the negative 1 with respect to x is ln, absolute value of x, plus c. Now, this one you definitely need to know is a special case, because if we went through our rules, add 1 and divide by it, negative 1 plus 1 is 0, and then you can't divide by 0. So this is a special case, but we know that if you have x to the negative 1, or 1 over x, which is the same thing, the antiderivative is going to be natural log absolute value of x plus c. Don't forget your plus c. And again, if you take it backwards, our special cases, you would get 1 over x if you took the derivative. The integral of e to the x with respect to x would be e to the x. don't forget your plus c. And remember, when we did special cases, the derivative of e to the x is e to the x. Now, this would be the integral of a number raised to an x with respect to x would be step 1, rewrite it, divided by the natural log of the base plus c. So here's an example. If I had the integral of 2 raised to the x with respect to x, step 1, rewrite it, divided by the ln of the base, which is 2, plus c. Don't forget your plus c. Now again, why does it work? If I took the derivative of this, you would get the original back. Now, the last two just remind you that if I had two things that are being added or subtracted, you would take the integral of each one. So if I had the integral of x cubed plus 1 with respect to x, I would take the integral of x cubed with respect to x plus the integral of 1 with respect to x. In the integral of x cubed, you add 1, which would be 4, divide by it, plus the integral of 1 would be 1x. Let's talk about why. This is a 1, but if it had a variable, it would be x to the 0. And if I added 1, 0 plus 1 is 1, divided by it, I'd have x to the first over 1, which is x, 1x. Don't forget your plus c. Now, the constant multiple rule basically says if you have a number in front, that number stays in front. So the integral of 5x to the third dx, the 5 stays in front, and we take the integral of x to the third. Add 1, 4, divide by it. Don't forget your plus c. So this would be 5/4 x to the 4 plus c. Okay, let's do some practice problems. Now, I'm trying to give you a mixture of problems, so I'm going to go over these, but you need to do these step by step and make sure you can do them on your own. So if I had the integral of 1 over x to the 55 with respect to x, I would first rewrite it. Remember we talked about rewriting it makes it easier to deal with. So instead of the integral of 1 over x to the 55 with respect to x, I do the integral of x to the negative 55 with respect to x. Remember when we move it from the denominator to the numerator, the sign changes. So this would be x to the negative 55. So when you add 1, you get negative 54. Divide by negative 54. So our final answer would be negative 1 over 54. That negative goes to the denominator, becomes positive 54 plus c. Don't forget your plus c. And like we talked about before, the integral of 1 with respect to x, that's like an x to the 0 there. So the 1 stays. Add 1, so 0 plus 1 is 1. Divided by 1, x to the first over 1 is x. So 1x plus c. Okay, so let's do some examples. If I had the integral of x cubed plus x to the fifth minus 1 with respect to x, I would take the integral of each one. So x to the third, I'd add 1, you get 4, divide by 4. So that would be 1/4 x to the 4. Plus 5 plus 1 is 6, divide by the 6, that'd be plus 1 over 6 x to the 6. And then minus 1, minus, and we just learned that the integral of 1 is 1x. Now, if this was a 5, it would be 5x. So you can see a pattern there. And then don't forget your plus c. I don't need to put a plus c after each one. 1 plus c at the end is sufficient, because remember, if a number plus a number plus a number is still just a number. So your final answer would be 1/4 x to the 4th plus 1 over 6 x to the 6th minus x plus c. Okay. In the next example, we have the integral of x to the 2.1 plus 1 over x to the 1.1 plus 1 over x plus e to the x, all with respect to dx, with respect to x. So we rewrite it first. Integral, again, haven't taken the integral yet, just rewriting it. X to the 2.1 is fine. But we have x to the 1.1 in the denominator, so we move it up, it'd be x to the negative 1.1. 1 over x has the x in the denominator, x to the first, we move it up, be x to the negative 1, plus e to the x, all with respect to x. Now remember, we haven't taken the integral yet, now we will. So, the integral of x to the 2.1, we add 1, which is 3.1, and then divide by 3.1. X to the negative 1.1, we add 1, we get negative 0.1, and then divide by negative 0.1. X to the negative 1, when we add 1, we get 0, and we can't divide by 0. Oh, remember, that's a special case. So the integral of x to the negative 1 is ln, natural log, absolute value of x. Plus, the integral of e to the x is e to the x. Don't forget your plus c at the end. Now to simplify a bit, if I had x to the 3.1 over 3.1, there's a 1 in the front. So 1 divided by 3.1 is 10 over 31, x to the 3.1. Plus, if I had x to the negative 0.1 divided by negative 0.1, there's a 1 in front of the x. So 1 divided by negative 0.1 would be negative 10, x to the negative 0.1, or you can move the x to the negative 0.1 to the denominator. So it'd be minus 10 over x to the 0.1. And then bring everything down, plus natural log absolute value of x plus e to the x plus c. Okay, the next example, if we have the integral of e to the x plus 3 raised to the x minus 1 with respect to x, it's ready to go. The integral of e to the x is e to the x, plus the integral of 3 raised to the x, that's a special case, rewrite it, 3 raised to the x, divided by ln of the base, which is 3, minus 1, the integral of 1 is x, don't forget your plus c. So the final answer would be e to the x plus 3 raised to the x over natural log of 3 minus x plus c. The next example, the integral of 10 x to the 4 plus 2 x squared minus 3 e to the x with respect to x. Now remember, when we have an integral, we're telling it with respect to x. When we take the integral, the dx disappears because we've already taken the integral. So, ready to go, don't need to rewrite it. The 10 stays in front. X to the 4, add 1, that's 5, divide by 5. 10 divided by 5 is 2, x to the 5th. 2x squared, 2 stays in front, add 1, 2 plus 1 is 3, divide by 3. That gives us 2/3 x to the 3rd. Minus 3 e to the x, the minus 3 stays in front, integral of e to the x, e to the x. Don't forget your plus 3. So we have 2x to the 5th plus 2/3 x to the 3rd minus 3 e to the x plus c. The last two. So we have the integral of 2 over x to the 0.1 plus x to the 0.1 over 2 minus 3/4 x in the denominator with respect to x. Need to rewrite this one first. So still doing the integral, haven't done it yet. 2, but instead of x to the 0.1 in the denominator, move it up, 2x to the negative 0.1 plus, I can have a 1 over 2, which is 1/2 x to the 0.1 minus 3 over 4 is 3/4. But instead of x in the denominator, move it up, and it'll be x to the negative 1 with respect to x. So when I do this slowly, the 2 stays in front. The integral of x to the negative 0.1, add 1, which is 0.9, divide by 0.9. 2 over 0.9 is 20 over 9, x to the 0.9. Taking the integral of 1/2 x to the 0.1, 1/2 stays in front. 0.1, add 1, that's 1.1, divided by 1.1. Now, 2 times 1.1 is 2.2. 1 divided by 2.2 gives us our 5 over 11, x to the 1.1. To take the integral of minus 3/4 x to the negative 1, we bring down the minus 3/4. The integral of the integral of x to the negative 1, that's a special case, is natural log absolute value of x. And then don't forget your plus c. So the final answer would be 20 over 9, x to the 0.1, plus 5 over 11, x to the 1.1, minus 3/4, natural log absolute value of x, plus c. And then our last example. Taking the integral of 3 e to the x minus 2 parenthesis 1.2 raised to the x close parenthesis with respect to x. Okay, so we do each one. The integral of 3 e to the x, bring the 3 down. Integral of e to the x is e to the x. Now, just like the 3 was in front and we brought it down, in the next example, we bring the minus 2 down. And the integral of 1.2 raised to the x, we rewrite it, 1.2 raised to the x, divided by ln of the base, which is 1.2. Don't forget your plus c. So the final answer would be 3 e to the x minus 2 times 1.2 raised to the x over ln of 1.2 plus c. Thank you.